So in this class, we're going to start talking about compound inequalities. Before you get too far, first we want to understand what a compound inequality is. First of all, the compound inequality just means we have a collection of multiple inequalities. We're a bit more familiar with inequalities from the work we did before. So when we take the word compound inequality, that just means we might put multiple inequalities in one scenarios. So we would have multiple restrictions in the situation we want to describe. That's what we mean by compound inequality. And to get started working with compound inequalities in this class, we're going to only focus on compound inequalities with two restrictions involved. So generally your questions will have a collection of two inequalities connected by different words. And we say for a solution to a compound inequality, similar to the definition that we had for the word solution before. We say it is a number which, when we plugged into all of the inequalities we have, results in a true statement overall. And when we have a compound inequality scenario, generally we have two inequalities connected by the word and or by the word or. So when we consider whether a number gives us a true statement, there are different situations we might need to consider. First, if we have two inequalities connected by the word and, in order for the number to give a true statement overall, we need the number, the solution we propose, to make a true statement for both inequalities we're working with. On the other hand, if you're given two inequalities connected by an or, that means only one of the inequalities need to be a true statement. If that statement is true, then we say that number gives a true statement. The number is a solution overall. This might sound a little bit confusing just looking at the definitions over here. So we're going to look at some examples with specific numbers. That way we get a better understanding with exactly where we mean by both statements being true or one of the statements being true. And we can also practice with the different notations. So in example 1, we're trying to write the compound inequalities in interval, set, and number line notation. So the first one we look at is x is greater than or equal to 4 and x is greater than 2. And to kind of work with compound inequalities, first of all, we want to notice that we're just starting with the inequalities we're familiar with to get started. And to help us understand the restrictions, I like to use a number line to give us a visual representation. And over here, we would have a number line created. I want to incorporate both restrictions on the same number line. That's my goal, so that I can see them in the same picture and compare the values. Here I notice the cutoff value is 4 and we need x to be greater than or equal to 4. So if I were to just consider this first inequality, x greater than or equal to 4, that will be my number line notation because I can include 4 with a bracket and any value to the right of 4 will be included. On the other hand, the second inequality I have is x greater than 2. I just want to put that on the same scale. And I can put 2 over here, and I want anything to the right of 2 without including the value 2. And again, there's no boundary to the right, so I can keep going to the right. Now we can actually put the information together over here. Notice the word we use is and over here. So in order to work with a statement including the word and, we need both inequalities to be true. And what that means in the visual representation we created is in order for both inequalities to be true, we're looking at the part of the number line that's covered by both intervals over here. And if I want to look for the part that's covered by both areas, both intervals, then I can see this is a part of the region that I'm looking at. And now if I want to indicate this entire highlighted area, which is the overlap area, by interval notation, we can say that we are starting from the number 4, again including 4, because that's what's implied in our initial statement. And we can go all the way to infinity to the right, because there's no boundary to the right over here. Take a minute to make sure that entire idea of looking for the overlapped interval makes sense to you. so that we can produce the interval notation. If this makes sense to you, then we can translate the interval notation back to a set notation over here. So curly bracket is how we indicate it's a set. Variable here is x, and we want x to be greater than or equal to 4, which you can see is exactly the same as the initial first inequality we had. And lastly, to go back to the number line notation, notice we technically already use a number line to help us answer this question, but to produce a result that makes sense to the reader, whoever's just jumping into your conclusion, it's much easier to read the conclusion with only one interval included instead of having the highlights and multiple intervals included. That's why we want to organize the information and just say overall the only restriction we have is a number 4, and we want it to be anything to the right of 4 over here, with 4 being included. And that will be the number line notation we get for the end statement over here. Next, if we want to compare what happens when we have the same inequalities but connected by the word or, we're going to look at part B. And to start part B, I would do exactly the same thing, that I would draw the number line with the 2 inequalities involved, which we already did. And in this case, if we want to consider the word or, that means only one interval or one statement needs to be true in order for the overall statement to be true. And visually what that means is we're going to look at the number line, and we're going to include anything that's been covered at least once or covered by at least one interval overall as we drew it. So now if we look at it, we can see the part of the area that's been included by at least one interval. If we again try to highlight it, it would look like this entire interval over here. And in this case, we can see that our final result, if we were to use the interval notation, will be starting from 2 all the way to infinity, because that part is covered by at least one interval. And if both are true, great, but we just need at least one of them to be true. And then in the set notation, we can go ahead and write x is greater than 2. And again, it's not a coincidence that we get exactly the same as the second interval over here. Lastly, for the number line notation, again, we want a neater presentation. For the final result, we would get from 2 to infinity. So 2 is excluded just as the initial inequality, and we want it to go all the way to infinity. So there's no bound to the right. And that's how we work with a statement connected by or. So now make sure you take a minute to kind of compare the differences in the results. The only difference between parts A and B is that one is connected by and, the other is connected by or, and they produce very different results at the end over here. And if you're good with this part of the comparison, we're going to try our hands at another set of problem so that you really get an understanding on what type of scenario could happen when we have a compound inequality. So in part C, we're working with the statement x is greater than 6 and x is less than or equal to 5. So to get us started, I'm going to go ahead and draw the number line, including both intervals again. First of all, x is greater than 6. If I were to draw it, it would look like this. Second of all, x is less than or equal to 5. So let's say 5 is over here. I want to include 5, but everything less than that or to the left of that as well. And that's what we would get. If now you look at the statement connected by and, remember we said visually we're looking at where the 2 intervals overlap. That's where both intervals are included. Both inequalities are true statements. So now if we look at that, we notice that these 2 intervals don't overlap at all over here. This is a slightly different scenario than what we looked at in parts A and B. When there's no overlap, that indicates that there's no solution when things are connected by and, because there's no overlap. And based on this, we can say that there is no solution. Alternatively, if you want to use a set notation, we can say that the solution is the empty set. So this is just an alternative way to state it. And just so we're clear, this is the empty set over here. And that's how we would answer this question. On the other hand, if I want to see we have x greater than 6 or x is less than or equal to 5, we are just looking at where the number line has been covered by at least one interval. And we can see this actually works out because there's no overlap of the two intervals. The final result of part D will just be identical to what we already implied on the number line. So to use a number line notation, I'm just going to bring down what I already drew over here. And now for the notation, for the other notations, we can use the set notation over here. And for set notation, we're just going to use x and state exactly the same inequalities we had. And I like to go from the smaller values to the larger values. So I'm just going to say x is less than or equal to 5 or x is greater than 6. That's the statements we had to start with. And lastly, for the interval notation, we are again going from left to right. So to go furthest left, there's no boundary. So we're starting from negative infinity. And then the first stop we have to make is at 5. 5 is included, so bracket. And now notice we have more than one interval to be included overall. This is a new thing that we have to work with for compound inequalities, because before we only had one restriction, so one interval will be sufficient. Now with multiple intervals, multiple restrictions, we want to introduce this new notation, which looks like a U over here. And I like to think about this as similar to the word U, because U stands for union. And union in our indication, as you would guess, just means or over here. They mean the same thing. And when we have that union, that's the connecting symbol for multiple intervals. Now I can write the second interval starting from 6 going all the way to infinity, because I have no bounds on the right either. So with interval notation, we would actually have two separate intervals connected by the sign for union, which looks like a U over here. And that's how we would work with compound inequalities to indicate the final result in different notations. Take a minute to make sure you understand all the differences or the different scenarios we have encountered before you move on to the next part to try your hands on these problems.